In 7.8, we're going to look at limits that are what we call indeterminate forms. Indeterminate forms are limits where the numerator, limits of a quotient where the numerator and denominator both tend to 0, or the numerator and denominator both tend to infinity. Okay, so these are indeterminate forms, and we have to either do some algebraic manipulations to figure out what the limit is, or apply this rule that we'll be learning here called L'Hopital's rule, which sometimes helps when we have an indeterminate form. So L'Hopital's rule says under certain conditions, the limit as x goes to c, and that can be x going to infinity, of f of x over g of x is equal to the limit as x goes to c of f prime of x over g prime of x. And we have to start, let me make it clear that we must start with an indeterminate form. In other words, f over g is going to 0 over 0, or f over g is going to infinity over infinity. So when we have that indeterminate form, then we can take the limit of f prime over g prime, and this sometimes helps because sometimes f over g is indeterminate, but f prime over g prime is not. So in number 1, as x goes to infinity, log x goes to infinity, so does log x cubed, and the denominator x is also going to infinity, so this is an indeterminate form of the form infinity over infinity. And so we're going to apply L'Hopital's rule. So we're going to write that this is equal to, and we'll write that it's an infinity over infinity limit, so therefore we're going to use L'Hopital's rule, and we'll apply it now. So it's equal to the limit as x goes to infinity of the derivative of the numerator, we'll use the chain rule here, over the derivative of the denominator, which is 1. So here we have limit x goes to infinity. I'm just going to rewrite a little bit. 3 times, and here we have log x squared over x. And again, we have an infinity over infinity limit, so we're going to do L'Hopital's rule again. So let's write that we do have this indeterminate form, so we're going to try L'Hopital again. All right, so we have limit x goes to 3. Sorry, limit x goes to infinity. Let's see how that 3 crept in over there. Let me change these to infinity. Okay, we just have this 3 in front, this constant. And now let's do L'Hopital again. Okay, derivative of the numerator, again, chain rule. Derivative of the inside is 1 over x, and derivative of the denominator is 0. So we're back to another quotient. All right, sometimes we have to apply L'Hopital more than once, and we just have this 2 times 3, this 6 in front, and we have log x over x. Again, infinity over infinity, so one more time we'll do it. All right, so one more time. Again, we have this type of limit, so we can apply L'Hopital. Okay, this will be the last time. Okay, now take derivative top and bottom. All right, and now we just have 6 times 1 over x as x goes to infinity. This is 0. So finally, we've finished taking the limit, and we see that this original limit is 0. In number 2, we have another limit where the numerator tends to infinity, and so does the denominator. So right away we'll apply L'Hopital, and we're going to justify it with this little statement, infinity over infinity, so we're going to use L'Hopital. All right, and here we go. So derivative of the numerator and the derivative of the denominator is just e to the x. And just one more time we'll do it. This is another infinity over infinity limit. So once again, L'Hopital. And in the numerator we have 2. In the denominator, once again, e to the x. All right, so here we no longer have an indeterminate form. Now the denominator is going to infinity and the numerator is staying at 2, so this limit is 0. In number 3, we don't have a quotient. We have the limit as x goes to 0 of x squared times log x. X squared is going to 0, log x is going to minus infinity, so this is like 0 times minus infinity. All right, in order for it to be of the form 0 over 0 or infinity over infinity, we're going to take x squared and rewrite this in the denominator as 1 over x squared. And keep that ln x in the numerator. Now let's look at this. As x goes to 0, this tends to 1 over 0, or this tends to infinity, and this tends to minus infinity. So that's of the correct form, infinity over infinity. And so now we're going to apply L'Hopital's rule. I think we only have to apply it once. So again, we have infinity over infinity limit, so we're going to apply L'Hopital's rule. All right, so we have limit x goes to 0. Derivative of the numerator is 1 over x. Now in the denominator here, we have x to the minus 2. So take the derivative and we have minus 2 x to the minus 3. And let's just simplify this expression. Let's multiply top and bottom by x cubed. Okay, so now we're just simplifying the expression. Multiplying by x cubed, so here we still have that negative 2. And in the numerator, we have x cubed over x. Okay, let's just divide over here by x, and we have x squared. So that's limit x goes to 0. X squared over negative 2, and that's equal to 0. In number 4, we have a limit where the base contains an expression involving x and the exponent also. So in this case, we're going to take the limit of the log of both sides. So we're going to write y is equal to the limit. X goes to infinity. 1 plus 2x. And here we have 1 over 3x. So in order to bring this down, we're going to take the log of both sides. So we're going to figure out what log y is. So that's limit x goes to infinity of the log of this expression. We want to bring down this 1 over 3 to the x in front. That's why we took the log. So here we have limit x goes to infinity, and here we have 1 over 3 to the x log 1 plus 2 to the x. All right, let's just put that 3 to the x in the denominator. Three to the x here, log 1 plus 2 to the x, 1 plus 2x here. And now as x goes to infinity, the numerator is going to infinity, and so is the denominator. So this is of the form, this is going to infinity, and so is this. So this is of the form infinity over infinity. And we're going to apply the rule, L'Hopital's rule. All right, so limit x goes to infinity. In the numerator, we have 1 plus 2x in the denominator. We're taking the derivative of a log. Derivative chain rule, a 2 comes out. And we just have a 3 in the denominator. And as x goes to infinity, this tends to 0, 2 over infinity, or 0. So this tends to 0. All right, so what we conclude is that log y is equal to 0, and exponentiate both sides, and we have that e to the ln y, which is the same as y, is equal to 1. So our limit is 1.